Hey guys, we're going to do another chapter 3 video here for section 3 in our textbook. So 3.3 is our topic. And the big question today is how can you use function notation to represent a function? So we are working on what is a function. We've talked about vertical line tests. We've talked about linear versus nonlinear functions. But now we're going to get into notation. And notation means how are we going to write it? What is it going to look like in symbols and on paper? So that's kind of where we're going with this today. And to kind of start us off, there's a little bit of an analogy that we use in math. When we talk about functions, we often refer to something called the function machine. And there's actually no such thing, but the idea behind the machine is we think of like a conveyor belt in a factory and how something goes down the belt and into the machine and out comes a product. So if you've ever watched any of those like YouTube videos on like how things are made, like how crayons are made or how chocolate's made or anything like that, and you've watched the factory portion of it, you'll see like all the things going down the conveyor belt and then the machine does all of its work. Usually people are involved too, and out comes the product. So we call that an input and an output. And when we talk about functions, we talk about input outputs also. So it's the same idea as like we want something to go through this machine and out comes a solution. So the function machine analogy is just something you hear of a lot, and I want you to be familiar with it. Here's how we are going to draw it. This is my function machine, and if I was you, I would try to draw this in my notes. It's not super fancy looking, but there's on top here, this is the input. You can see the arrow pointing in, and on bottom, this is the output. You can see the arrow pointing out. So we've got input and we've got output. And so you should probably sketch that in your notes. And inside is the function. Whatever's happening in the machine is what we call the function. So function f. So I'm going to label on my machine that the input, which we call x, goes on top, and the output, which we're going to call f of x, goes on bottom. And this is going to be kind of new notation. So it looks like f parenthesis x, but we call it f of x. So I'm going to write that as a main idea over here because that is our main basis of function notation, f of x. And it's really equivalent to when we have an x and a y. This is the y part of the variable, which I'm going to explain later. But I want you to get familiar with the words f of x. And we're going to try a problem here. And here is our first problem. We are going to evaluate a function. We're going to evaluate f of x equals negative 4x plus 7. And we're going to evaluate when x is equal to 2. So what that means is x equals 2 is going to be our input. And we want to know what's our output. So in terms of that function machine, here's another variation or picture of my machine. My in is going to go into my rule, and out is going to come my answer. So my input is x equals 2, and I'm going to put it into this rule, f of x equals negative 4x plus 7. And over in this blank space over here is where I'm going to do my math to get my output. So here's my function, negative 4x plus 7, but I want to input 2. So you see where the x's are. I'm going to replace with blank spots. I'm going to take out the x, and I'm going to replace it with the number 2. Instead of f of x, I want to know what's f of 2 equal. And it would be negative 4 times 2 plus 7. And then that's easy math for me to do. Negative 4 times 2 is negative 8. If I add on a 7, negative 8 plus 7 would be negative 1. And I've got my output. F of negative 2 is equal to negative 1. My output is negative 1. And so there's my solution when I evaluate. Look at my work, because this is something you're going to have to get used to. Notice all the way down my work where this arrow is. Each step I'm writing f of 2 equals, f of 2 equals, f of 2 equals. I'm being very detailed in showing my work. And then out comes my answer, negative 1. So my output in my machine down here is negative 1. We put x equals 2 in, out came negative 1 when we ran it through the function. Okay, so let's try another one. Let's evaluate a new one. We'll call it w of x instead of f of x. We'll change up the variables. W of x equals 6 minus x. And I want to evaluate when x is equal to negative 1 or x is equal to 4. So we're going to do 2 inputs this time. So here's my function, w of x. first, maybe we'll focus on -1. So I'm going to make a blank spot where my x's are, and I'm going to replace it with -1. So it's going to be w of -1 equals 6 take away -1. Now I know these two minus signs are going to turn into a plus, so this is really 6 plus 1, which is 7. So we just got our output, it's 7. Now I got to do it again over here, but I'm going to use x equals 4 as my input. So I'm going to replace my x's with 4, and I'm going to have w of 4 equals 6 minus 4. And 6 take away 4 is 2, so my output is 2. So we've now got two answers, two values that we've evaluated. W of -1 is equal to 7, and W of 4 is equal to 2. Okay, your turn. I want you to try this a little bit. So here is your directions. Can you evaluate each function when x is equal to -2 or x is equal to 10? So two inputs here, -2 and 10. And I'm going to have you try two problems also. So here's the first one. F of x equals 0.5x. F of x equals 0.5x. Go ahead, pause the video, and evaluate that function. Okay, so you're supposed to be done and unpausing the video to check your answer now to see if you did it correctly. You have -2 and 10 to check. So f of -2 means you had to do 0.5 times -2. Well, that's -1. And then f of 10 means you had to do 0.5 times 10, which is 5. Let's try it with this function. What if it was g of x? G of x equals x over 2 plus 1. Pause the video, hit pause again, and see if you can evaluate. Okay, let's check your answer. Let's see if you're doing this correctly. Test yourself. Like, this is a good way for you to see it. Do you really have this down? So I'm going to put -2 in. G of -2 means I would have -2 over 2 plus 1. Well, fractions mean divide, and 2 divided by 2 is 1, but it have to be a -1. And -1 plus 1 is 0. So the answer is G of -2 equals 0. Let's try it with 10. If I put 10 in, I'd have to do G of 10, and it would be 10 over 2 plus 1. And 10 divided by 2 is 5. So 5 plus 1 is 6. There's my output, 0 and 6. So G of -2 equals 0, and G of 10 equals 6. Those are my values. Okay, if you didn't get the same answer as me, look for your mistake. Try to backtrack through the video and see if you can figure out what did you do differently than me so that you can kind of fix your own error and not make that mistake again. Okay, moving on. Example 3. Let me show you another variation of these problems. So, new function, we're going to say for h of x equals 2/3 x minus 5. I want to find the value of x for which h of x is equal to -7. This is a different problem. I actually want to find the input, not the output. This is kind of in reverse. I want to find the value of x for which h of x is equal to -7. So here's the output. What does the input have to be to get -7? Now I could sit here and try to guess that, but I don't want to guess that. I want to use some algebra. So here's what I'm going to do. If h of x is equal to -7, I know what h of x is. I'm going to draw an arrow under it. Remember, it's this, 2/3 x minus 5. So I'm going to replace it with 2/3 x minus 5. But it's got to be equal to -7. Oh, cool. Put a line down the middle. Get x isolated by itself and solve for x. Take that -5 and add it to the other side. -7 plus 5 is -2. Take that 2/3 x and get rid of it. You could divide the 2/3. You could start by just, I like to just multiply the 3 away first. That's one strategy. That'll get rid of these 3's over here, and you'll just have a 2x. And then 2 times 3, -2 times 3 is -6. So 2x equals -6, and then just divide that 2 away, and you'll have your solution. -6 divided by 2 is -3. There it is. There's our input. X is equal to -3. And we can check it to prove that we're right. Like, if we want to go for that, like, advanced level 4 work, here's a great way to be at an advanced level 4. Check your solution. If -3 works, we should be able to tell pretty fast. So remember what h of x was equal to. H of x is 2/3 x minus 5. Well, now, if I replace the x with my answer, -3, I better get negative 7. So let's put negative 3 in here. H of negative 3 would be 2/3 times negative 3 minus 5. Okay, let's do a little math. 2 times negative 3 would be negative 6, but it's over 3, so negative 6/3 minus 5. 6 divided by 3 would be 2, so it would be negative 2 minus 5, and negative 2 take away 5 is negative 7. Yes, check, it worked. That's what you wanted. You wanted the output to be negative 7, because that was the original question, and the input is negative 3. And I would say, like right now, if I was grading this like on a test or a quiz, this looks pretty advanced. This looks like level 4 work, because I've solved and I've checked, and it's super organized. Look at every step being labeled really neatly. That's what you want your work to look like. All right, your turn. Test yourself and see if you have the hang of this. Here is your you try problem. For f of x equals 1/2 x plus 3, find the value of x for which f of x would equal negative 10. Okay, this is the time. Hit that pause button, try it by yourself, and see if you got this down. Okay, so unpause the video. Let's check your answer and see if you really do have this. So f of x is equal to negative 10. Well, we know what f of x is. It's 1/2 x plus 3. So I'm going to write 1/2 x plus 3 has to equal negative 10. Line down the middle. Let's solve for x. Let's isolate it. Take that 3 away to the other side. Negative 10 and negative 3 make negative 13. To get rid of the 1/2 x, times the 2 to the other side. Negative 13 times 2 is negative 26. There's our answer. X is equal to negative 26. And I could stop right here and be done. And on a test, I would score a 3. I'd be proficient. I've got the right answer and all of my steps. But if I was really going to go for that high level 4, I would check my answer. I would figure out, is f of negative 26 really going to give me a negative 10? I would go test that. Okay guys, so that kind of ends our video here. I hope you have a little idea of what f of x is and how to input a number and look for the output. And I hope the function machine analogy, when you hear that again in class, it makes a little bit of sense. Thanks for watching, guys. Bye.